So in the last section, I talked a little bit about the spectrum of light and how we have all of these different wavelengths. But in fact, our eye is only actually capable of seeing 3 different wavelengths of light. Our eyes see red, green, and blue. You'll notice in the visible light spectrum that you don't even see the color magenta. And what happens is our brain takes red and it takes blue and it merges those together and we get magenta. So in fact, we've got this visible spectrum, it's linear, but our eye wants to close the gap and turn it into a circle, hence the construct of a color wheel. So this is what's known as the RGB model because our 3 wavelengths of light are red, green, and blue. And when we add all of these wavelengths together, we get pure white light. RGB is our additive approach, but we also have a subtractive approach, which is the opposite. So additive uses light to mix colors, and the subtractive method uses pigment or ink. So our printers still print in CMY, which is the subtractive method, and CMY stands for cyan, magenta, and yellow, which are 3 primary colors of the subtractive method. And if we add those 3 colors together and overlap them all, we get black, and the absence of those colors is our blank white sheet of paper. In both the additive and the subtractive approach, if we have 2 colors or 2 hues that are opposite each other on the color wheel, these are referred to as complementary colors. When we add those 2 colors together, we actually cancel the colors out and we get 50% gray in the middle. So not only are we reducing all of that color information to gray, but we're actually converting the luminosities, so we're at 50%, halfway between light and dark. So we talked about the additive RGB color model, we talked about the subtractive CMY color model, and we actually have an additional subtractive color model that predates both of these. And this is referred to as the RYB color model, which stands for red, yellow, and blue. And when we mix these together, we're going to get our secondary colors. We can also mix our primary colors with our secondary colors, and those are our tertiary colors, and we can keep mixing our tertiaries with our secondaries or our primaries, so on and so forth, which is going to create these small iterations of color in between our primary and secondary colors. So when we get into the concept of color harmonies and how we mix and match these colors, these rules that we'll talk about in just a minute are actually going to apply to both the RGB and the CMY and the RYB color models. And they're both going to work because we're applying to slightly different palettes, but the rules are still the same. For this particular tutorial, I'm going to use the RYB color model. It lends itself to a bit more of a painterly palette and a painterly aesthetic, which is something that I'm always trying to infuse into my own work. And we'll be talking about that for the remainder of the tutorial. Not surprisingly, the color green has many associations with nature, given its prevalence therein. It is the grass we walk on, the leaves on the trees, the promise of bounty and life and vitality that sustains us and helps us grow. Today, green lights universally signal that a system is turned on and working as it should. In many video or computer games, green signifies both health and completed objectives. Green also has been widely used to represent toxicity and poison. It's the color of greed and envy, in part due to its association with wealth, both poisons of the mind.